Welcome to The Explainer. Okay, let's dive into this. Strategy. It's a word we hear literally all the time, right? Tossed around in boardrooms, classrooms, everyday life, usually dressed up in all these fancy buzzwords like synergy, vision, or ambition. But what if I told you that most of what we actually call strategy is, well, just a wish list? Today, we are breaking down some absolutely profound insights from Richard Rumelt's book, Good Strategy, Bad Strategy. We're zooming in on Chapter 9 specifically to show you that true strategy, it's something much, much more mechanical. It's not just some lofty idea, it's literally the architecture of winning.
Think about your own work for a second. When you're staring down a huge challenge, do you just, set a vague goal, make a choice, and tell yourself, hey, I just got to try harder? That is the exact trap so many of us fall into. We kind of assume that if we just pick a direction and push with enough sheer effort, we're going to succeed. But Rumelt argues something completely different. He says a real winning strategy isn't just a choice, it is a meticulously constructed design.
And this brilliantly illustrates the massive difference here. Strategy as a choice is really just picking a vague goal, like, say, deciding you want to climb a mountain, and relying purely on grit to get yourself to the top. Strategy as a design, though, that is a whole different ballgame. It's about engineering a coordinated construction of interlocking parts. True strategy requires fitting these pieces together almost like ascending steps to overcome one specific massive challenge. It isn't a standalone decision, it's an architecture of action. To really understand what this looks like in the real world, or actually, scratch that, the ancient world, we got to go back over 2,000 years.
Section 1. Hannibal's masterpiece at Cannae, the deadliest trap in history.
The year is 216 BC. The stakes, absolutely massive. Rome is a superpower, and Hannibal of Carthage is facing down an unprecedented Roman army. We're talking 85,000 men. Vastly outnumbered, Hannibal didn't just turn to his guys and say, fight hard. No, he choreographed an absolute masterpiece. Let's move to Alxi and see how this builds. Step 1, he positioned his troops in an outward-facing arc and told the center line, the Gauls and Spaniards, to stage a mock retreat. Step 2, the Romans see this, they push forward, and they are drawn right into the center of the arc. Hannibal literally used their own aggressive mobility against them. Then, step 3, his heavy infantry holds the sides while his cavalry sweeps around and completely closes the trap from the rear. He designed a mechanism that used the enemy's own momentum to lock them in a box.
The result was horrifying. The Romans were squeezed together so tightly that they physically could not even raise their swords. The men stuck in the center, they just waited helplessly. Hannibal completely nullified Rome's massive numerical superiority. And he didn't do it with magic. He did it with pure, anticipated, and highly coordinated design. He engineered a system where every single moving part of his army acted in perfect, lethal harmony.
Section 2. The mechanics of integration. Building the ultimate driving machine.
All right, let's pull ourselves out of ancient history and drop right into modern engineering. Because that exact same concept, coordinating parts into a masterful whole, is absolutely what separates average businesses from industry titans today. Think about what makes a BMW 3 Series the ultimate driving machine. You can't just buy the most expensive, generic parts off a shelf somewhere, bolt them together, and expect to get that legendary feel. No way. You have to tune everything. The chassis stiffness has to perfectly balance the engine weight, the front suspension dampening, that must harmonize with the tactile feedback of the steering wheel, and all of it, the whole shebang, must hit a specific price-to-performance ratio. You're out there adjusting dozens of parameters to find that ultimate competitive sweet spot. You are literally designing for the maximum smile per dollar.
Or take a look at PACCAR in the heavy truck business. Their strategy is this coherent, high-ground design that is specially tailored for owner-operators who want custom luxury features. If you tried to build a Frankenstein's monster truck, taking medium-priced designs meant for fleet buyers, throwing in some cost-cutting engineers, but then trying to sell that mess to luxury owner-drivers, it would fail instantly. A Frankenstein design fails because all the pieces are fighting each other. Good strategy demands pieces that are carefully, meticulously fitted together into a specialized, coherent whole. Section 3. The Voyager Weight Constraint. Engineering the impossible at JPL.
Now you might be wondering, where does the pressure to build these incredible designs actually come from? Well, Richard Rumelt points to this fascinating perspective from his own background as a young systems engineer at NASA's Jet Propulsion Laboratory. When they were designing the Voyager spacecraft mission to Jupiter, the team was given a brutal constraint: 1,200 pounds. That was the absolute maximum weight the Titan II IC rocket could lift. So the crucial point here is, Constraints force painful but absolutely incredible trade-offs. You can't just throw more resources at the problem. You have to design your way out of it.
It's much like how NASA's Surveyor lunar lander had to be built around the strict, resolved ambiguities of what the moon's surface actually looked like. Voyager had to be built around strict weight limits. Every single subsystem on that craft, the radio, the antenna, the fuel tanks, they all had to compete for pounds and ounces, and they had to tightly integrate if they were going to survive the journey.
Just look at the cascading engineering trade-offs they had to face. If you cut the weight of the power unit, well, now you have less power, meaning you've got a weaker radio. A weaker radio means you suddenly need a highly focused dish antenna just to reach Earth. But wait, a focused antenna requires incredibly precise sensors to point it perfectly. And precise sensors, those require more fuel for attitude control. Do you see how every single choice impacts the entire system? It's this beautifully terrifying web of competing needs.
Section 4. Resources versus tight configuration. The strategic trade-off.
This brings us to the absolute core business thesis of this explainer. What Voyager teaches us, and what Rumelt so brilliantly points out, is that there is a fundamental trade-off at play here. Now, what's really interesting about this slide is it shows that if you have low resources, you have a massive need for clever, tight integration. But if you have high resources, say a giant budget or a powerful monopoly, your need for integration drops. Clever integration actually acts as an ascending staircase that elevates low-resource teams. Resources and tight coordination are literally substitutes for each other. The greater your challenge and the fewer resources you have, the more you desperately need a brilliant design to survive.
But we have to be honest here for a second. This power absolutely comes with a cost. Tightly integrated designs are magnificent, yes, but they are incredibly hard to create. They force you to have a really narrow focus, and frankly, they make you much more fragile to change. Think about a Formula One race car. It is a tightly integrated masterpiece that will absolutely destroy a generic SUV on a track, right? But it can't drive over a speed bump. It certainly can't go off-roading. Extreme integration means sacrificing your flexibility.
Section 5. The tragic arc of success. How winning breeds defeat.
And this leads us to the most dangerous part of our journey today. Because what actually happens when that tight, scrappy design works? What happens when you win? Follow this timeline with me. In year 1, an upstart has to use an incredibly tight, clever design because, well, they have no money. By year 5, that brilliant strategy wins, yielding massive, potent resources. But by year 10, those easy profits breed laxity and bloat. The massive resources actually make leaders lazy. They stop doing the hard work of design and integration because they think they can just buy their way out of any problem. And then, by year 15, the inevitable decline hits as a new, hungry upstart invades their space. The very resources that success brings end up killing the strategic discipline that created that success in the first place.
So, what should we really take away from all of this? If you want to learn real strategy, it might be best to look away from the massive, bloated incumbents. Don't study the aging Goliath who's just coasting on massive resources and historical momentum. Instead, study the young David. Look at the tightly crafted, meticulously integrated actions of the upstart who is actively invading the market. Because that is where you will see the true mechanics of competitive strategy at work. Which leaves us with this final, absolutely vital question for you. Think about your current projects right now, your team, your company. In your own work, are you putting in the hard effort to build a beautifully coordinated BMW? Are your parts perfectly tuned to work together? Or are you just lazily substituting resources, throwing more money, extra hours, uncoordinated effort, and calling it a true strategic design? Take a hard look at your trajectory today before the tragic arc of success catches up with you. Thank you so much for joining me on this explainer, and we will see you next time.